Hi everyone and welcome back to PrepFusion. In today's video, we will discuss about all the questions from electrical engineering branch which came in GATE 2025 examination. Okay, this will be memory based questions. So whatever questions we got from various sources, we'll try to discuss all the questions. So in few questions, the options may be bit incorrect, okay, because the data we haven't got the like all the data, but mostly the options will be correct. Only whatever data we have got, mostly we'll try to answer that, and this will be the most authentic solution. Like here we will try to solve the controversial questions as well, and we'll give you the proper answer of the controversial questions which other coachings have given wrong. Okay, we'll try to discuss all that. Okay, so let's start. Like mostly talking about the level of the paper. The level of the paper mostly was on the easier side, not on the difficult side, not on the moderate side, and but you cannot predict anything about EC. EC can come moderate, EC can come difficult, it can come easy. You cannot predict anything else. Okay, but let's start with our discussion. We'll start with general aptitude. So if I start with general aptitude, this first question is very easy, just like a number system question. So here option A will be correct. Then this is again an English question. So in this question as well, option D will be correct. The next question is this one. Okay, so good is evil, genuine will be what? This also will be here. Option A will be correct. That is counterfeit. Okay, in few places the options may not be exactly matching. So just be careful about that. Okay, like counterfeit will be the correct answer, but these options may be different. That may be different. Okay, so here again, like you have to fill the question mark. What will be the question mark filled with? So for this question, the option will be answer will be option B. This FG belongs to 42. Okay, so like this general aptitude question were pretty straightforward and pretty simple. This also is a very basic straight line equation of straight line equation. For this, option A will be the correct answer. Next, if I move like this, I will explain those questions which I find bit like tricky and good. Like simple questions I will not explain, I'll just simply tell you the answers for simple questions, and I hope you already know the solutions and all those things. Okay, so for this question as well, option A will be the correct answer of this question. Okay, now I will come to engineering mathematics. So this was the first question of engineering mathematics. Like you have to find out the direction derivative, and this is like very standard, very basic question. So I don't have to explain this, just simply the field is given, the direction is given. You have to find the gradient of this. Then after finding the gradient, then take a dot product with this, with the unit vector. So the unit vector will be ax plus 2ay divided by under root 5, and then you take the dot product, and then you will reach to a solution. Okay, not that difficult, pretty simple and straightforward. Okay, so finally it will be 1 by under root 5, and that is equals to 0.447. But I think many students are telling you have to answer to nearest integer. So nearest integer for this will be 0, then 0 will be the answer. If you have to answer in terms of nearest integer, here you have to evaluate the contour integration. So you can use the Cauchy's integration theorem, or you can directly put z equals to e raised to power I theta, because here your contour is mod z equals to 1, so magnitude will be 1, and like it will rotate a whole circle. Okay, so like if you see, like there are no like the poles in the inside the contour, no poles inside the contour, hence obviously there is no residue, hence the integration also will be 0. Okay, so let's come to the matrix question. Again, this is a very simple question. Here I can see that this, right, the first row and second row are just of opposite signs. Here also first row and second row are just opposite sign. So like what will be the type of the solutions? Here I will get infinite type solutions. Why? Because rank of A will be equals to rank of AB, and both are less than total number of variables, that is 3. Okay, rank is 2 here, so that's why it will be infinite solutions. Pretty simple and straightforward. Here as well, again you have given this P matrix. Simply you have to find out what is P square. So simply you do the P square, you multiply again P with this. What you will see, you will observe you are getting this option, 2p minus I. This is identity matrix. Okay, so you will get the answer as 2p minus I. Now let's move on to the next question. This, right, this again, I don't know if you like exact data I don't have, whether this is MCQ or MSQ. So if this is MCQ, simple, like this is a very standard question that we, like, I think every radio grader teaches. So here like you have to find out the value of n for which r like the divergence will be independent of r. So if you find out the divergence, it will come out to be 2. Okay, the value will come out to be 2. This will be option C, not A, sorry, this will be option C. Okay, this will not be A, this will be option C. So next, this one, right, given v1 v2 are two eigenvectors of a symmetric matrix, two distinct eigenvalues, which of the following statements is true? So like there is a property of symmetric matrices that their eigenvectors will always be orthogonal. Their eigenvectors will always be orthogonal. This is a property of a symmetric matrix. So this I think you should know. And if like two matrices are orthogonal, right, then if I take the inner dot product or outer dot product of the two matrices, okay, inner or outer dot product of the two matrices, I will get simply 0. This will be simply 0. Okay, so option B will be correct because like inner product will be 0, so that's why option B will be the correct answer of this question. Now this question is again pretty simple. You have to find out the possible values of x and y for which I am getting a minima. So if you find out the minima, how do you find out the minima? You make the partial differentiation of the function with respect to x equal to 0, you make it partial differentiation of y equal to 0, then you find out that condition you have rt minus s square, that needs to be greater than 0, that condition you equate. Okay, I hope you remember, I am not explaining it. So you will get one finite set of values, that is C. Option C will be the correct answer in this case. Next is network analysis. Okay, so network analysis, this just a like statement based question, like new type of question they have given, nothing else. Okay, basically they are just trying to say that nulliter is a circuit element in which both current and voltage will be 0 always. Okay, so if a resistor is connected with it, now I don't know how the resistor is connected, whether it is connected in series or parallel, but it doesn't matter. If it is connected in series with a nulliter, this is the nulliter, right? This is the nulliter, some element nulliter. Okay, if it is connected series with the nulliter, I know current across the current through the nulliter will be 0. Hence, it is in series. So current through the resistor also will be 0. And property, what does the property of resistor say? Voltage will also be 0. Okay, if current is 0, voltage also 0. And if it is connected in parallel with a nulliter, same thing. I know voltage across the nulliter is 0. If voltage is across the 0, they are parallel, so voltage across the resistor will be 0. If voltage is 0, then current will also be 0. So basically, the combination behaves as a nulliter itself. Okay, because voltage resistor also takes in 0 current and 0 voltage, so it will also behave as a nulliter. Overall, the circuit also will be behaving as a nulliter only. Okay, let's move on to the next question. This question was good. This question was from AC. So here you have been given, like, these are all AC quantities. Okay, V3 is given as 199, V2 is given as 9, V1 is 200. So you had to find out the power dissipated by the load. So here how you used to find out? First, right, you have to find out the current through the load. All these are voltmeters, right? They will take in 0 current. Okay, these are all voltmeters. The voltmeters take in 0 current. So voltage across the resistor is 9. Okay, so current across current through the resistor will be 4.5 amps, which will go into the load. But this is the magnitude. This is the magnitude of the current that is going to the load. Okay, but I know the voltage. Yes, I know the voltage. Voltage is 199 across the load. But I have to calculate the phase angle as well. My power dissipated will be voltage into current into cos phi. Okay. So how do I find out the cos phi? Now this was a very good question. So here I know my input voltage Vs. This is Vs. Vs will be equals to simply the summation. These are all complex numbers. Okay. This V2 plus V3. These are all complex numbers. So if I draw a phasor diagram, V2 will be in the, let me write V2 as reference, then V3 you can either write it as lagging or leading. I'm just assuming that V3 will lead something, okay, because it is a complex load, there will be some phi angle, it will lead by phi angle. Okay, now if V3 is here, right, then the current across the load also will be here, that is IL, because it is a series connection, so IL will be here, right. This is IL, right? This is my IL, 4.5 amperes. IL and V2 will be in same phase because they are just simply resistance. So whatever this phase angle I have, if I calculate this somehow, then I will be able to write my answer. So how to calculate the phase angle? I know the summation, complex summation, phasor summation of this is Vs as written here, right? So if I take the summation, this will be equals to Vs. So I can use the parallelogram law. So what is the parallelogram law? It is simply your Vs will be equals to whole under root V2 square plus V3 square plus 2 V2 V3 cos phi, the angle between them. Okay, now from here I am expecting you can do it, not that difficult. So from here if you do, you will find some value of cos phi, and if you find the value of cos phi, you put V, magnitude of V, that is 199, you put I, that is 4.5, and you put cos phi, and you will get to your answer. Okay, this is how you solve this question. This was a good question. Again, this again is a good question. Okay, network I will say came towards the moderate side only. Okay, so this, right, two coupled circuits are given with L1 and L2, and their mutual coupling is M, and their like coefficient of coupling is 1. Okay, so they are asking us what will be the value of I1 by I2 if the energy stored is minimized between the circuits. So if you know the energy stored uh, between a coupling circuit, sorry for my voice, that's because my throat is not great. I'm currently a bit sick, so that's why a bit of snoring will happen. And so this will be L1 I1 whole square plus half L2 I2 whole square plus M I1 I2. Okay, this is the equation for energy stored. Okay, now I have to minimize the energy. How do I minimize? I partially differentiate this with respect to I1. Okay, this will be L1 I1 plus M I2. So my I1 by, because I have to equate this with 0, right? To maximize or minimize anything, I have to equate this with 0. If I equate this with 0, this will be minus my I1 by 2 will be minus M by L1. Okay, this is the first condition. Next condition is if I make del E by del I2 0. If I make del E by del I2 0, similar type of equation will come I2 plus MI1. So this will come out to be, I will again equate it with 0. It will be minus L2 by M. Okay, so minus L2 by M is here B, and minus M by L1 is here C. So BC will be your correct answer for this question. You can verify with that RT minus S square and all those things. I'm just not going into that. I'll just drink a bit of water. So let's now move on to the next question. So like this is again a simple first order transient question. For a stable first order LTI system, different output values are given at different time instants. You have to find out the time constant. So time constant is like basically uh, 4 tau is the time at which I reach steady state or something, 99% or something. So like you can solve this very simple question. Option B will be correct. So 2 will be the time constant in this case. You can solve the definition of time constant is very simple. It's a first order circuit. Okay, so next is this one here. So question was given question is not difficult, straightforward, but they have told you to round off to the 1 decimal place. So answer was coming out to be 4.05. Okay, so you have to round off. So either you can do 4.1 or 4.0, and don't worry, gate will give enough provision. So like this range will be given, 4 to 4.1 range will be given, and whoever has marked 4.1 and whoever has marked 4, both will be correct. Now this is a very good question. Okay, and this we have taught in our full course. Like it's free present on the playlist as well, and Himanshu will also make a video on this, so make sure to watch this video. Okay, so this video will come just, I think, just after this video or just before this video. Make sure to watch this question. This is a very good question, and they are framing this type of question now. Okay, this type of good question in transient. Previously this type of question like generally doesn't come previously, and many educators are making mistake in this question, many educators. Okay, so make sure you watch this video, and this we have this type of concept we have taught multiple times. Also we have taught with diodes as well. Okay, so let's just watch this question. This will be the answer. Okay, the waveform will not be triangular between -1 to 1. It will be like a exponential, but it will be very near to the 0. It will be very near to the 0. Okay, something like that. This one you have to find out the curve between Vxy and Xy. This was also very simple network question, not that difficult. So this for this answer was option A. Okay, control system question. Now we'll come to control system. Again, this was again a very straightforward question. You have to find out the like range of k for which the system will be stable or unstable. Like you can use the route. Okay, simple route, nothing else. It's the second order system. It's not even a third order system. Second order system. Okay. So this will be option A. For k greater than 2, the system will be unstable. Yeah, sorry for the interruption. Again, like my throat is really hurting. So this again is a very simple question. Like you have to find out the sum of the magnitude, like sum of the magnitude of the poles. So how do you find out the poles? If the system matrix A is given from the characteristic equation, simply if you write the characteristic equation, it will be lambda minus trace of A, that is plus 3 lambda plus determinant, that is 2. From here you will find the roots, that is -1 and -2, and this roots, right, are actually poles of my system. So the magnitude will be -1 plus -2, simple 3. Okay, so 3 will be answer, nothing like steady. So this one was a okayish question. So here they have given the Nyquist like contour. They are told that I have a OLTF G of S which is totally stable, whose all poles lie on the left hand side. So P will be 0 in the Nyquist equation. If you remember, my N was equals to P minus Z. Okay, so P is 0. N is N they have given me in the counterclockwise direction. It is encircling once. In the counterclockwise direction, it is encircling once. Okay, so they are like whatever data I have, I don't have the information about the Nyquist contour. If you assume the Nyquist contour to be in the clockwise direction, then you will write here n equals to 1. Then your like encirclement will come in the counterclockwise direction. But if you write here 1, right, your P is 0 minus Z. Z is coming out to be -1, which is not possible. Okay, not possible. So obviously I have to assume that my Nyquist contour is in the clockwise direction. If my Nyquist contour is in the clockwise direction, then everything will be sorted. Sorry, my Nyquist contour is in the counterclockwise direction. If my Nyquist contour is in the counterclockwise direction, so this n will be -2. -2 will be 0 minus Z. So Z, so not -2, sorry, -1. So Z will come out to be 1. Okay, so Z comes out to be 1, which means I have a right hand side pole, closed loop pole. That means my system will be unstable. Now I don't have the options. So whatever information I have, according to that I am discussing, system will be unstable. Now according to the options, if the options are given, then you will tick mark that one. Okay. This was again a okayish question. So gain, cosine of frequency, all those things are given. You have to solve basically KD. Find the value of KD. So not that difficult. Basically how you would have solved it. So phase margin is given, right? Phase margin is basically 180 plus angle of OLTF is the phase margin. Okay, at omega equals to omega GC. Correct. So if I put here, right, if you put your OLTF is D of S into G of S, okay, plus 180 angle of this equals to phase margin is 45 degrees, whatever 45. Yeah. So I know that if there are two complex numbers which are getting in product, the angle will be simply added. If the angle is simply added, it will be like simply angle of D of S plus angle of G of S. The angle of D of S will be simply tan inverse omega GC. You have given omega GC, they have given as 10 radian per second, so it will be 10 kd. Okay, I am not solving it, I am just explaining how you can solve, and this angle you can solve and from there you will get your value KD as 0.1. Some expression will come. I remember that this expression used to come tan inverse. So this is not tan. So this is tan inverse. 10 KD was 45. So 10 KD will be 1. So KD from here will be 0.1. Okay. From what I remember, this was the actual answer, like equation. At the end you will get this one. Okay. Now this one is like a simple question only, but the way many teachers are solving is lengthy. You can solve it without any knowledge of state space also you can solve this. Okay, so how? But you have to know Laplace, right? So you are given this x1 dot, x2 dot and initial conditions are also given, and they have given is r of t is u of t. So I have to find out x1 dot of t at t equals to 1. For that I need the expression of x1 dot of t in terms of t. Okay, so how do I do that? So I will take the Laplace inverse. Okay, so if I take the Laplace inverse, this will be of the x2 dot of t, this will be x2 s x2 of s minus the initial conditions. You cannot ignore the initial condition, that is x2 of 0 equals to r of s. R of s is what? Laplace transform of u of t, that is 1 by s. Okay, x2 of 0, you can see from the matrix, this is the x2 of 0, right? The second row is 0, so it is 0. So my x2 of s is 1 by s square. So x2 of s is 1 by s square. Now from here you can put this value. Now I will take the Laplace inverse of this equation. So it will be s x1 of s minus x1 of 0 equals to 2 x2 of s. So x1 of 0 is 2, x1 of 0 is 1. So this will be x1 of s equals to x2 of s is 1 by s square, so it will be 2s square plus 1 and s is here. Okay, now I will divide by x1 of s, I will divide by this will be 2s cube plus 1 by s. Now if I take the Laplace inverse, it will be like this is a standard formula, like standard relation. I hope you remember this. Or there is one formula s raised to power n plus 1 equals to t raised to power n, some Laplace transformation is there, right? I hope you remember. This will come out to be t square, this will come out to be t into e of t. Okay, now you put t equals to 1, this will come out to be 2. So without any state space knowledge, nothing, I simply solve. Okay, so this is how you solve, right? Don't have to go into state space or something, no need to go to that. Now this, right, this is again simple power question, you have to find out the power. This is the basis of signal, 7 will be the answer for this question. And this also like simple integration, e of t, del of t are given, all the definitions you know, simple integration will, and answer will come out to be -9. Okay, this also h of 0 you have to find out, h of omega is given. So again, like I think there is some property with like Fourier transform, something like that. So this you can solve using that property, 200 will be answer. Okay. Now coming to this question. Okay, so if I come to this question, so for this as well, this was not that difficult, given that then you have to find out the relation between x of n and y of n. It comes out to be this. Okay, option B will be correct. Okay, now this question is again pretty simple, just you have to apply the property. What is the property? Property is, if I take the area on both sides, right, if I take the area of y of t, then if I have x1 convolution of x2 of t, then the area, what does the area become? Area simply gets multiplied, area of x1 of t multiplied by area of x2 of t. The convolution sign, right, gets into dot. Okay, it gets multiplied. This is a property. If you apply this property, then you will be able to find out this area simply, right? Then you will be able to find out the area. This will come out to be 1.5. Okay, so now let's move to this question. This question is like pretty like theoretically this question is pretty good. What they have asked is, given that the impulse response of LTI system is u of t. Impulse response is u of t, that is my h of t is u of t. Okay, I have a LTI system whose impulse response is u of t. Fine. Okay, which of the following statements is correct? For every input, output will be bounded. For every input, output will be unbounded. For some bounded inputs, output may be unbounded. For all bounded inputs, output will be unbounded. Okay, anyways, you can go with the optional elimination, and with optional elimination, option C will come. But what is the concept behind this? So if I have a LTI system, right, and my like impulse response is u of t, unit step function. So let me choose few inputs. Let me choose few inputs and let me see what output I will get. So if I choose a unit step input, if my x of t, right, here I have x of t. Okay, inside I have x of t, right. If my x of t is u of t, unit step itself, if my x of t is u of t, then what will be the output? Simply, if you remember something, that whenever I have u of t, right, as my impulse response, then the output is simply integration, running integration, right? Output is simply running integration, if you remember this. Okay, so output is not from 0, from minus infinity, running integration. So I will just integrate. If I integrate unit step, this will be my output. So my output will be simply a ramp. So my input was bounded, right? It was bounded from 0 to 1, but output, right, I'm getting unbounded. It will go towards infinity, right? So this option C is satisfying. For some bounded inputs, output may be unbounded. Option C is satisfying. Now let me choose another example. Let me choose this very simple example, that when I will get the output as bounded as well. For some bounded inputs, output will be bounded as well. Okay, so let me choose a finite duration signal. Any finite duration signal you can choose. Any finite duration signal you can choose. X of t. Okay, I am choosing this signal. Okay, then what will be the output? Output will be simply the integration, right? And what is the integration of this? It is simply this, right? Then it will be 0. No, it will not be 0, right? It will remain constant. Okay, it will remain constant. I hope we know basic integration. So it will remain constant. So output will be simply this. Okay, so is this bounded output? Yes. Was my input bounded? Yes. So for some inputs, for some bounded inputs, I am getting unbounded output. For some bounded inputs, I'm getting bounded output. Okay, so for some bounded inputs, output may be unbounded. Okay, maybe. So yeah, option C will be correct for this question. Okay, straightforward. So in digital as well, this was a very simple question. Just you have to use K-map. Okay, and this would have simplified. Okay, so just one thing for electrical guys, from the trend is this questions from digital come really low, really low. So I will recommend electrical people to not focus on digital too much. Okay, so analog this question came. Okay, again this was like you have to find out the gain of this, pretty simple question. So option here answer will be 2 here. Simply the answer will be option B. Why? Because common source provides a phase of 180 degree, that's why it can be used as an inverting amplifier, and common gate provides a phase of 0 degree. I hope you know all these things, this has been taught, so that's why option B will be correct. This one, so this one, like people have solved this will simply work as buffer. Why? Because like you will simply apply VGC. If VGC is applied, then here Vin will come out. If here Vin comes out, this will also be Vin. Okay, this is VO, right? This VO, and this VO will come here because you are applying VGC. VO will be equals to Vin. But how you are applying VGC, that you understand, right? How you are applying VGC, because negative feedback is present. Can you confirm that? Can you confirm negative feedback is present? Yes. How? So here if you see, if I go around this loop, right, if I go around this loop, how much total angle I am getting? So if I start from here, this negative sign will provide minus 180, then this positive sign will provide no phase shift, and here I will come back to same phase. So overall if I rotate, I am only getting minus 180 degree phase shift. Okay, so here also the same thing, right? If I rotate here, I am getting minus 180 degree phase shift. So both op amps are in negative feedback. So that's why VGC, virtual ground concept, will be valid. You have to check whether the op amps are in negative feedback or not. If they are not in negative feedback, then everything will go to waste. You cannot apply VGC. In this case, it is applicable. So your circuit will act as a buffer. Okay, so this was again a standard circuit, only standard circuit. This like simply like Himanshu solves, so not that difficult. So for this, option C will be the correct answer of this question. So now we will come to core. So machines were like on the moderate side, questions were on the moderate side. This question was simply on the maximum slip formula, like this. I hope you know the formula. According to that, V by F will be constant, and according to that, answer will come out to be 100 volt to 12.5 hertz frequency. Okay, so if I move on to this next DC imaging question also, this is again in the same pattern. You have to find out the external resistance. So this will come out to be C for this question, 23.22. Again this like this was a theoretical question, so I think many students may not know this, so you have to be just careful about this. So this was a MSQ as well. Which of the following instruments are used to synchronize an alternator? So it is voltmeter and synchronoscope. Why is synchronoscope used? To like synchronize between the phase difference, and voltmeter is used to like synchronize the voltage difference. Okay, so both should be used. Voltmeter to synchronize the voltage difference, because if there is a voltage difference, then you cannot connect it to the bus, right? You have to check if there is no voltage difference. So that's why both are important. Okay, so next let's move on to the power electronics. This is again a very simple question only. This type of question we have solved multiple times in our classes. So the like you have to find out the average power. How do you find out the average power? Just find out the average voltage across this. If you find out the average voltage, you will be able to find out the average power, and I will not tell you how you can find out the average voltage. Okay, so this will come out to be 90 watts, and yeah, this is again like this can be called as a network question. This can be called as a power electronics question. This is like you have to find out the power factor, input power factor. So it will not be just cos of 60, sorry, cos of 30. Cos of 30 will come out to root 3 by 2. It will not be that. Okay, and that is also present in the option. So you have to find out the overall IRMS, okay, overall VRMS, and then you have to multiply. You have to find out the apparent power. Apparent power will be IRMS into VRMS. Okay, how do you find out IRMS? IRMS will be 10 by root 2 whole square plus 2 by root 2 whole square plus 1 by root 2 whole square, like this. Okay, then whole under root and VRMS will be 300 by root 2. You multiply, you get the apparent power. What will be the active power? Active power will only be contributed due to these two, because only they have the matching frequency. These are all higher frequency components. This will be the power due to this will be 0. This I have explained in my full course, so I will not explain over here. So or here if you find out, ultimately your answer will come out to be 0.847. Okay, this will be the answer for this question. Now this question few teachers might say like there can be MTA, or like they can say this question is solved wrong, but I think this question is like totally fine, nothing is wrong with this question. So they have given you some input and rectifier circuit is given, and output I have a RLE load. Okay, and this is but they have not mentioned about the load current, and they have also not mentioned about the inductance. Is it very high or not? But they have not mentioned about the input frequency. So ultimately what you have to find out, the average you have to find out this angle alpha. So this is the average voltage expression. How do I find out this value, angle alpha? So what you can do is, first they have given me the power dissipated across the resistor. What is the power dissipated across the resistor? It is IRMS whole square into R is the power dissipated across the resistor. So from here I will get IRMS. IRMS will be equals to what? IRMS will be equals to 8 amperes. Now I will assume my current to be constant. Okay, I will be equals to IRMS. Why? Nothing is mentioned. They have not mentioned about the input frequency, so I will assume that. If you don't assume that, you will not be able to, like, the question will become then something else. Okay, so so here, if it is a constant current, that means my IRMS will be equals to I average. All this I have explained. So I average is 8 amperes. So my VU average will be what? It will be I average into R plus V of L, and V of L average will be 0. We know that in a periodic cycle, plus 500. I know VO average expression. I put this. I know IO average. What is IO average? IO average is 8. I know R is simply 1. So from here you will get the value of alpha. Alpha will come out to be 35.9 degrees. Okay, so pretty straightforward question. Okay, the peak value. This is again a very standard question. This is like the first or second question that we do in rectifiers. Okay, so the peak value of current will come out to be 2 Vm upon omega. This will be the peak value of current. Okay, so it will come out to 20.707. Again in power system, few theoretical questions came like this one. Newton rational method. Uninterruptible power supply will be treated as what? What type of bus? So like it's a bit controversial. According to me, it should be slack bus. Why? Because slack bus is also used to provide power during fault or balancing, something like that. And this UPS also is used when like there is some problem in the power supply system and it is used. So I think they are similar. So I think it should be slack bus. It should be treated as slack bus. This one is from load flow analysis. Answer for this question will be 0.3, and you have to find out the bus 1 voltage, and pre-fault voltage will be 1 for these cases. Okay, so not that difficult. Again this question is again like some capacitor bank question. Again very simple question they are asking. This will be simply P into tan phi minus tan phi 2. Okay, and this power factor, all these things, this we have taught, like I hope this you learn in power systems multiple times. This again came in voltage regulation. Again, like you have to find out the condition for voltage regulation, because you have to find out the maximum voltage drop across the load. So if there is maximum voltage drop across the load, voltage regulation will be very good then. Okay, there will be very low drop here. Okay, so according to that you can solve. So answer will come out to be 0.98. The power factor will come out to be 0.98. Okay, so measurement, again bridge sensitivity question came. Again this is standard question, 1.96 millivolt per ohm. This I have solved. This type of question I have solved multiple times in my full course. This also, in this case, right, whenever you are in doubt, just write down the equation. 1 by R will be equals to 1 by R1 will be equals to 1 by R2. Okay, you choose R1 R2 to be maximum error. Okay, maximum error will be what? 5%, right? So this will be R1 will be equals to 105, R2 will be equals to 905. Then for other case you choose it to be minimum. R1 will equals to 95, R2 will be equals to 100. So this will not, sorry, this will not be 905. This will be 5% of this, right? This will be 45. Sorry about that. This will be 855. Okay, so just put the values, you will see the maximum from the nominal value, right? From the nominal value maximum it will go 5%. Okay, 5% of the nominal. So answer will be 5% for this question. Again, this question came on EMFT, like cylindrical capacitors came. This is a basically basic formula based question. This I have explained in my EMFT course. You can go and watch the YouTube video. So for this question, the epsilon r will come out to be 9. Okay, so that's about it for all the questions. I hope you have enjoyed this discussion. So like we'll also obviously bring EC as well, and I hope your examinations went well, and let me know if you want any more discussion about any more questions, so I will discuss. So that's it. I hope you learned something, and until then, happy learning and all the best for your upcoming examinations. Thank you.